Examples in calculus. The product rule. This is video 1. How to determine when the product rule must be used. It includes exercises with solutions. The following list of 7 short videos shows all videos, including this one, that involve the product rule to find the derivative of a function in an example or an application. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. An example of a function that is the product of 2 separate functions. The function y, where y equals 2x squared times e to the x, is the product of 2 separate functions on the right-hand side of the above equation, circled briefly in purple. The first function is 2x squared, and the second function is e to the x. Since y is the product of 2 separate functions, the derivative of y must be found using the product rule. The notation for the derivative of y is y dash x, or dy by dx. Reminder: the function e to the x. The function e to the x is called the natural exponential function. It is a very important function in many subjects, including calculus. The numerical value of e is equal to 2.71828. Although this numerical value is e to the 1, it is usually written as e unless the numerical value itself is required. Further examples. Each of the following functions is the product of 2 separate functions. Identify the functions. 1. 3 into 2x plus 5 is the first function, and e to the x is the second function. Initially, y may seem to be the product of 3 separate functions, 3, 2x plus 5, and e to the x. But since 3 into 2x plus 5 can be expanded to 6x plus 15, y is the product of just 2 separate functions, 3 into 2x plus 5 and e to the x. 2. r into 4 minus 3r is the first function, and e to the r is the second function. In this case, the derivative of a will be a dash r, or dA dr. 3. t squared plus e to the t is the first function, and root t is the second function. In this case, the derivative of s will be s dash t, or ds dt. Exercises. Each of the following 6 functions, displayed without commentary, is the product of 2 separate functions. Identify the functions. Note that in question 4, line R is one function, and in question 5, cos A is one function. Line R is log base E of R. Line R can also be written with a lowercase l and said as natural log of R or ln R. There are other variations. You should pause this video now and complete all 6 questions. Then check your answers with the solutions on the next screen. Solutions to the exercises. The solutions below are displayed without commentary. The derivatives of the above functions must be found using the product rule. Question 6 is discussed on the next screen. To review the above solutions, you should pause this video now. In question 6, z minus root z is the first function, and z plus root z is the second function. However, j can be simplified by multiplying out the brackets on the right-hand side of j, and then cancelling out like terms as follows. J equals z minus root z times z plus root z equals z times z is z squared. Z times plus root z is plus z root z. Minus root z times z is minus z root z. And minus root z times plus root z is minus z. After multiplying out the brackets equals z squared minus z after cancelling out like terms. Note that multiplying out the brackets or removing the brackets is called expanding. Since j equals z squared minus z, the derivative of j can now be found using the power rule, which gives j dash z equals 2z minus 1. Thus, the derivative of j has been found far more easily and with less chance of error than if the product rule had been applied to the 2 brackets in the original equation. If you got one or more of these questions wrong, return to the exercises. You should try to understand what was wrong and why you got them wrong the first time, then repeat the questions until you get them all correct. When solving questions from your textbook, similar to the questions in the exercises, you will find it helpful to have this screen displayed so you can use it as a template. You should then find this topic simple and beautiful. Cheers.